So just want to say hello, good morning, good afternoon, depending on where you are. And thank you for joining us for today's webinar entitled Advance Your CFD with FieldView. Post-processing is an important phase in the simulation process. So we want to make sure our Converge users have all the information on all the options. So today we are hosting one of our valued partners, Intelligent Light. Thank you for your time today. And if you have any questions, again, type those into your question box. And with that being said, I will be turning control over to Eve Marie.
Thank you, Tiffany. Hello, everyone. I'm glad we have a chance to be with you today. And so I'd like to send a special thank you to our partners at Converge Science for putting together this event. So this is the outline I have for you today. After a very quick introduction, we'll go into some demonstrations, and I'll try to proceed in 3 steps. First, we'll look at the basics, how the interface between Converge and FieldView works, how you can post-process your results. Then we'll do a bit of simple automation. And finally, in the last and in the third stage, I will try to show you some of the ideas we have for people working with large unsteady simulations, like most Converge users. And at the end, as Tiffany mentioned, we'll keep time for a Q&A. So please keep your questions for the end, but you can also type them in the question area, and Shane will help me in addressing them as we go. Okay, so moving on to a quick introduction. This is our corporate slide. Intelligent Light is the name of a company, but we're better known for the name of our product, FieldView. You can see that we've been around for quite a while. Our company, Intelligent Light, has a background in aerospace. Most of the large aerospace companies in the world do use FieldView for their post-processing. You can also see a number of references, such as research centers like NASA, JAXA, DLR. All of these people use post-processing, rely on post-processing on FieldView for their difficult post-processing for dealing with their very large cases. But we also have quite a large footprint in the automotive industry, especially in Japan. If we take the example of a company like Toyota, for instance, Toyota is fully standardized on FieldView for its post-processing. So that gives us quite a broad view, between aerospace, automotive, and other industrial fields, a broad view of all the CFD applications and the different problems that people have to tackle. We're also in touch with hardware vendors. We have partnerships with a number of CFD vendors, such as Converge. And for instance, we are in constant contact with the Converge developers to make sure that the interface between our 2 tools works seamlessly and there's no problem or data being lost in the conversion. So let's move on to a few preliminary words. I want to take a step back and look into the problems that we believe Converge users are having now. And we see that mostly as a drawback of the more affordable HPC that we see as a big trend. And so what's happening is that for CFD users, it became very easy to be running CFD solvers 24/7, especially with a tool like Converge. Now that people have got rid of the problem of meshing, with high-quality automatic meshing, it's now very easy to make a quick change in a Converge input file, rerun Converge in batch for different flow conditions, maybe a different design, and boom, you generate another terabytes of data for a new simulation, and you have all this data that you have to look at. Another drawback of HPC is that people now have to share their HPC resources, and so they end up having all those large result files, most of the time on the result on the remote system, on the file system. And so having this data being remote creates additional problems. All of that is happening in a very constrained environment, especially for people working in the automotive industry, but not only. CFD is supposed to provide answers, and more design cycles are happening, and so people are under a lot of pressure, and so they actually have less time to tackle this new challenge that we call the data bottleneck, and find solutions to look at more and larger CFD simulation results. So just a few words about how we try to resolve this with FieldView. FieldView is a tool that is CFD focused. This is a CFD-only post-processor, so it has all the capabilities you will look for when dealing with CFD results. It's quite easy to use and remember. It's very efficient. It's very fast and reliable. Let me say that also it doesn't have a limit on the number of cases. So your limit is the memory of your system. It doesn't have a limit on the number of windows. It can read data from many sources, a lot of different solvers, but also experimental results for doing comparison. It can be fully automated. People, for instance, use it in batch all the time for generating from just a few results, images, plots, up to full reports. And it comes with a lot of solutions for large data handling, and I'm going to say a bit more on that during the demonstration. So with no further ado, let's move on to the demonstration section of this meeting. And in this first step, we are going to look at how you can export your results from Converge to the FieldView format, so you can read them into FieldView, and then start with some very simple post-processing steps. This is Converge Studio, so I was mentioning the fact that I'm working from the post-processing tab over here. So I've provided a case name. We have a number of out files that have been generated by Converge. And what we need to do is provide a file type. So there's a couple of options for FieldView. The one that I recommend is called FieldView version 14 format. Why version 14? This is just a name that the Converge developers picked because it is based on the format that has been introduced at that version, but it actually reads in all FieldView versions. Then I will pick a number of out files, so I just say all of them, then all the variables, and also the parcels are going to be exported to the FieldView particle path format. So I'm going to take all of these variables, and then I just hit the convert button, and you can see that the tool starts writing these files to my working directory. So obviously the same can be done if you're more a user of the command line tool post-convert. The same can be done. It will be option 7 for the FieldView version 14 format. And the reason why I'm picking this format is that it's based on our most recent FieldView particle path format. It's a compact, high-performance binary format that will read really quick into FieldView. And so if you're working with a large number of particles, that will make a big, big difference. So I'm just doing the conversion here for a number of time steps. Let's go see. This is a directory where I'm writing the files. You can see the particles files and the FieldView UNS files being written. And to give you another rough idea of the data we're going to work with, it's a small tutorial file. I wanted things to be quick, but it's already about 200 megabytes of data that we are going to deal with for each time step. So the conversion is done. Let me go now to FieldView, and Shane, please let me know if you get a freeze again. That will be hard for me to tell. So from FieldView, for reading this data, we're going to go to File, Data Input, and we have an option right here to get data from Converge inside of FieldView. So I'll just adjust my settings and go in our work directory and pick these files that we've just generated together. I'll pick one of them, and FieldView will be able to tell by itself that this is a transient case by recognizing the files having the same root names with an increment. So it's asking me whether I want to read that as a sequence of an unsteady data set, and I'll just say yes. All right, so at this stage, the one time step that I've selected has been loaded into FieldView. So I'll move on to the next step and create the geometry that I want to look at. So from here, I will select a number of boundary types with shift-click, hit OK, and you can see all geometry appearing over here. Let me get rid of the outline. All right. People probably recognize, as I mentioned, this very well-known Converge tutorial. So when you're dealing with such an internal geometry and internal flow, there are a couple of tricks for being able to look at what's happening in the inside. An easy one is to turn on transparency, so we can see what is happening inside, like here. And then if I create a cut plane, you can see it appearing. So it's very easy in FieldView to change the direction of the cut plane from X to Y or Z. I can also change the location very easily. Let's go back to a Y plane. We'll make it constant, and we'll activate scalar coloring. So here we have a list of scalars, so you can recognize actually the list from when I was doing the export. We have the three components of velocity, but the magnitude of velocity is missing from the export. So what we'll do is create a new variable that will be based on the magnitude of the velocity vector that is available here at the bottom of the list. So I click OK, and once I've done that, we are getting a new variable, magnitude of velocity, that we'll use to color my plane. All right, so let's just a few settings. We'll change the color map. All right, and from that point, it's quite easy in FieldView to change the location. Here I'm just doing a sweep of the different locations, and that's the first way to investigate what's happening in my 3D flow. I can also move the slider over here or type in a value if I want something specific. For instance, this value here is going just through the middle of the valve, which is a good way to look at the exhaust gas that are coming up at this stage of the engine cycle. Right, so after just a few minutes, you can see that we already have an image that I'm quite happy with. One thing that we are missing here is the legend, so I will bring it up. Let's move it closer to the geometry. By default, FieldView is telling me what variable I'm looking at, but I can also overwrite that. So we'll just say velocity. I can type in y equal to say that this is a y plane, and this is the value of the plane location. All right, let's make a few more adjustments. We'll make that a bit bigger. Okay, let's add a frame and the border around it. All right, so with this, I'm already quite happy with the image. I'd like to show you another trick when you're working with internal geometries like this. Another option, instead of using transparency, is to threshold the object based on geometry. So here I'm going to threshold it based on Y, the same location as the plane that I'm looking at. And this way I'm revealing the plane inside of our geometry. So once I'm happy with the result, I can go ahead and save the work that I've done. So with FieldView, you save your work with what we call restart. So I'm just going to go ahead and save a complete restart, which is saving the complete information I have to reproduce my session at that stage. If I want to save an image, I can go and do File, Save Image, Graphics, and have a number of graphic formats I can pick from. But another option is to just go ahead and do Edit, Copy, graphics. So I'm copying the current session to my clipboard. And if I come back to PowerPoint, create a new slide, I can paste the image right there without even having to go through a file. So it's actually an even faster solution. Let's go back to FieldView. Another export that I want to show you that is actually richer than just a fixed image is to go for a 3D PDF. So I'm going to provide a name and a location for that PDF, maybe webinar as well. And what FieldView is doing at this stage is that it's writing my current session to a PDF, which is more than just a page. It's actually a 3D document that will let me visualize my scene with the Adobe Reader that most people are familiar with for looking at reports and so on. All right, so the export is now complete. So I close this. Let's go to my work directory. So this is the PDF that I've just created. You can see that it's quite small, just 25 megabytes. So it's easy to share with colleagues or share with customers. So as you can see, I'm now in Adobe Acrobat Reader. This is no longer FieldView, but it has a feeling of FieldView because the scene is exactly the same. And just the controls are different, but you can see that with some demotion, I have the ability to change the view. I can also zoom in on the object. Right, so that's a very nice way to share your results with people who don't have access to FieldView or people who don't have knowledge about CFD post-processing, and just include that inside a report. And so they have the ability to look at the results. You can see that the legend is also available and so on. Let me close the 3 PDF and come back to FieldView. I'm actually done with the first stage of that presentation. So let me go back to a few slides. So I just wanted to say a few words before the next step in our demonstration about the different ways that you can run FieldView. FieldView can be run directly as I'm doing now on my laptop. You can also run it in client-server mode. If you have a big system that has access to your large data, you could be running the FieldView server on that large system and then doing the rendering locally on your workstation or your laptop. The client will be accessing the license, but we also have a mode where the server will be providing the license. If you're connecting from home, for instance, or working from an airport, maybe you can't see the license, which is protected on your network. But there's a mode where you can run FieldView and get the license through the server, for instance, through an SSH connection. So that absolutely works. And that's great if you have a graphic card on your local system, because that's where the rendering is going to happen. But what we see happening more and more is also people sharing resources in terms of graphic capabilities, having fat nodes, for instance, on their clusters on which they're going to have a big graphic card, a lot of memory, and they want to do the post-processing over there. So if that's the case, FieldView can also work in this environment. And in that case, the rendering will be done on the server, on the remote system. And FieldView works really well with environments like VNC or DCV, where compressed bitmaps are being sent through the network and being displayed locally while the rendering is remote. The only one thing you may need to know about this mode is that you may have to launch FieldView with the -HRG command line option for hardware remote graphics in case you're seeing performance problem, and that's what's going to give you the best performance for running with remote graphics. And finally, in the same type of environment, if you have a cluster accessing your remote results, you could be running FieldView in batch over there. It's very simple to run FieldView in batch. You just use the -batch command line option when you launch it. This way, the GUI doesn't come up. We have support for both the FieldView language, which is called FVX, and also Python, and so you can have your Python scripts, and they will control all FieldView runs. And you will be able to generate images, generate animations, generate extracts that I'm going to explain in a few minutes, and also quantitative results such as 2D plots or CSV files can be written in that mode. And that also works if you don't have a GPU card on the remote cluster. So if you have it, we're going to take advantage and be faster. If you don't have it, we'll do software rendering, and we'll still have the ability to make images or animations over there. So let's move on to the second stage of our animation, and I'm going to try to leverage a little bit on the work we've done in that first phase and show you some very basic ideas of automation. So what I'm going to do is just go and open the file that we've saved together. All right, so let me move to my work directory. So when I saved the complete restart earlier, FieldView has also saved what we call a guide FVX, which is the equivalent FVX program to recreate all session. You can see here that first, FieldView will load the test case, load the data set. For instance, if I want to recreate the same image on a different case, I could simply change the file name over here or change the location. Then it's taking simple steps. First one being to create the boundary surface. Second one to create my coordinate surface. And after that, I have the view ready. So what I'm going to do is just get rid of the rest of this text file. And I'll do some very simple coding to implement additional automation. So let's just say that I want to recreate the same session and automatically save an image at that step. So that's done with a very simple script command that's going to do print graphics. Then I pick the format, so we'll do PNG, for example, and I call it my picture. All right, so let's save that change. And from a command line, we're going to call FieldView. I'll just do port known because I have another FieldView session running, but you don't have to worry about that. Then I'll do -batch -FVX. And yeah, I've called it complete.fvx. All right, let's try to run that. And if I didn't do any mistake or typo, that should work. All right, so FieldView is starting in batch. You won't see it coming up, but our console here is telling us the status. So it has read our data set. You can see the report of the number of nodes and elements, and you can see that the file had also been created. So let's go see over here in our work directory. Well, here it is, my picture.png. And if I open it, you can see that we do have an image of the same session, but that's been made in batch. So a lot of different things can be done with it. You can see that in one line I've made an image. In just one line as well, I could be making an animation. If I have a transient case, I can loop through the time steps and record the animation. And I can do many things with that, from very simple to the most complex tasks, or FVX language to support loops, conditional loops, iterative loops, functions. So that's how people do code very advanced reports, for instance, through FieldView automation. All right, let me go back to one more slide over here before we move on to the last section of our demonstration. Now I want to have a more specific look at one of the challenges we see, especially for people running Converge. As I mentioned earlier, it's really easy to run new unsteady cases with Converge, thanks to this great automated meshing. And the drawback of this is that people end up generating a lot of cases, a lot of time steps. and it's becoming very difficult to move, to read, to write those files, and it's taking a lot of time. So one of the solutions we recommend is to work with extracts. The idea of extracts is that you're going to generate much smaller files that are going to include only the surfaces that you want to look at. We call those extracts XDBs. They're frequently several orders of magnitude smaller than the actual data set. And so everything you do with it, such as moving them to a local workstation, reading them into FieldView, all of these operations are going to be much, much faster, and that makes it a lot easier, a lot more efficient to analyze unsteady results. So you have those objects, and it is on those objects that you do a post-processing, and then eventually you make analysis and make decisions on your design. So the idea of XDB is to split the process at this stage of the creation of the objects. And in addition to saving how those objects are being created, we're also providing a file format where you can write these objects. So we call this format XDB for extract database. And because we get rid of the 3D file of the big mesh and only keep the cut planes, the streamlines, the boundary surfaces you're interested into, you're still able to do your post-processing on these objects, but you have something that is many times smaller, as I mentioned, and it makes everything faster as you work with it after that. So in this third stage, what I'm going to do is generate some extracts based on the case we have loaded, and then I'm going to show you what impact that has and how you can work with this extract instead of the full case. All right, so let me go back to FieldView one more time. So from this point, if I want to generate some extracts, I'll go to Tools, Viewer, XDB Write. All right, I'll put them over here. I'll provide a file name. Then I need to provide variables that I want to export in my file. And the same idea that the fewer variables, the smaller the file. By default, FieldView is suggesting that I export all the variables that I'm currently using on my current objects. So I'll do that, but I actually don't need temperature and pressure, and I'll stick to the magnitude of velocity. And I will export that. So it's going to be pretty fast because I don't have much that I'm rendering in this session. All right, so let's go see over here. We have one file that has been generated. Webinar.xdb, and you can see that it's about 20 meg. And if you recall, initially we looked at the full volume files, and they were in the range of 200 meg per time step. So without much effort, and by already looking at a lot of surfaces, and especially we have the entire boundary surface, we already have a 10x reduction in size for the data we're working with. Right, so I'm not going to go through the steps of doing the export for the time steps. It's typically something people will do in batch, just as I've shown you earlier with the guide AVX file. I've prepared XDB extract, and so I'm going to load that directly to show you how we will work with it. So let me create a new window, move it a bit to the side to make more room over here. So once I have an extract, I can go ahead and load it by going to File, Data Input, XDB Import. I have a number of XDB files over here in a directory. You can see that we had a lot of time steps for this test case. All right, so I'm just going through the same steps as I've shown you earlier. Working with a case, I'm making the geometry again. I'll be able to load a view restart that we've saved together to apply the same view. And you can see that by default, the two cases are synchronized. So that's a great way to compare two designs as well, which is not what I'm doing here. But if you have multiple designs you want to look at, you can have as many windows as you want and have all the views synchronized like this. I'm going to apply the same trick to look at what is happening on the inside. Okay, And this time I'm also going to add to my session the particles that have been exported from Converge. All right, so let me go look for the FVP files. I'm not going to worry about the time step that I picked because FieldView is going to automatically synchronize the particles with the current time steps that I have from our XDB file. So that's what the warning message is telling me. All right, so particles have been loaded. Let's change the view a bit to make them more visible. I'll change my background to white. I need to change the coloring on the particles. And, all right, something like this. And I will also make them smaller with a scale that is based on the scalar. All right, that's better. So you can see that we have a lot of particles in this simulation. If I zoom in, make them one step smaller. Okay. So once that I've set this view, what I want to show you is that because I'm working with the XDB files instead of the large case, it makes it really fast to move from time step to time step. So as I activate the sweep here, FieldView is going to load the XDB file for the next time step, load the particles as well, update the view, and is going to store in the memory of my system all the objects that I have on screen. And that's going to cache kind of a transient animation, except that the entire 3D objects are cached, and that's going to then allow me to change the view, rotate, zoom around, while the transient animation is playing. So we'll just leave it a bit of time so that a few more time steps are being loaded. Maybe you want to address some of the questions that you mentioned, Shane, while I let the cache build a little bit.
Sure, I'd be happy to. Yeah, there was one question that came in earlier, which was asking generally about training. Do we provide training classes?
Yeah, that's a great question. Of course we do. So we provide it in different forms. It can be a customized class that we do at your location. It can also be a more standard one that we do at our central location in New York. But I have to say that honestly, not a lot of customers do take this class. What we hear most of the time is that after like a couple of hours on our tutorials, people are already able to work with their own data. People also use the FAQs we have on our website. We have how-to videos, and with the support of our support team, I think it's quite easy to get going with FieldView on your own data. So yes, we do provide training. I think it makes sense, especially if you have a large team of users that is going to start using FieldView at the same time. But it's quite an easy tool, so it's not a requirement to go for training.
Good. I'd also add to that a comment about our custom engineered solutions team. What we're seeing more often than requests for training is a request for automation, workflow automation, where we come in and work with your people, your best practices, and develop a workflow that's incorporates all these different things that Yves-Marie's been showing you, the XDB workflows, the FEX scripting, and trains you on how to use that as well. So that's an additional thing. So thank you for answering that question. I'm going to pass it back to you.
Thank you, Shane. Okay. So here you can see that I've stopped building it and I'm now playing back the cache sweep. So the time steps are changing, and because I have the objects in memory, I actually have the ability to change the view. I can zoom in over here. You can see that my two windows are still synchronized, but I could also have desynchronize them. I can rotate around and look at the unsteady animation from different angles and different zoom levels. So it's actually like thousands of unsteady animations in one once I've compiled this. And of course, the animation could also be saved to a video format. We support MP4, for instance, which is a format that YouTube or PowerPoint recommend in terms of portability and precision. All right, so I'll stop the animation and come back to my slides for our conclusion. So if you've been interested into the demonstration that we've given, let me tell you that we have more materials that you can find on our website, highlight.com. It has publications, visual library. We have more webinars, previous webinars that are also available. And if you'd like to try FieldView on your own data, we can give you access to a free 30 days evaluation. That's all I have for you today. I'll be happy to take questions if we've received new ones.
Yeah, there was one other question that came in here, which is what makes this better than others? I assume he's saying what makes FieldView better than other post-processors. You know, we tried to show during the demonstration, and I think Emery did show a number of advantages. If you'd like to kind of review them as compared to other types of post.
I think what we hear from our customer base is that FieldView is very easy to use, that it's easy to remember. I mentioned the idea of a training, and again, most people train themselves on FieldView based on our documentation and our tutorials. FieldView is fast and efficient. We've been going through benchmarks at companies where what matters the most when it comes to post-processing is the speed at which you can process results. People running large, very numerous simulations like Formula One, for instance. There are a number of Formula One teams that rely on FieldView because it is faster than other solutions. It's faster at reading the results, faster at creating the scene, and then you get more images in a shorter time. I think it's my final point is going to be that it's also the best solution if you want to attack really large simulation results, or if you have a lot of time steps that you want to look at. We can work on all the systems from the smallest laptop to the largest HPC. And so we have solutions for looking at all the simulation results, including the largest ones.
Good, yeah. So the same person actually asked a separate question with regard to PowerView and how we compare with PowerView. And I'll at least answer part of that, which is support, professional support. Our support team is often given compliments about how great it is to work with them and how they've, we have a team of people around the world who answer questions more or less around the clock, but we do get back to you within one day, and our team is often complimented for the responsiveness and the level of quality of our support. So with something like PowerView, where you don't have a professional support staff working with you, that's a big differential. Emery, do you want to mention anything else specifically comparing to PowerView?
Yeah, what our customers tell us when it comes to PowerView, we have a number of customers, we use both, is that FieldView is a lot more reliable. We've been talking a lot today about running FieldView in batch, the idea that with Converge you quickly get a lot of files, and so if you want to look at all these results, make a lot of pictures or animations, doing it in batch will help a lot. And we hear a lot that PowerView crashes a lot. So if you have a lot of runs, you will have to resubmit some of your jobs by hand, and that can be very bothersome for users. And some aspects like, I mentioned the idea of working hand in hand with the people at Convergent Science. We do a lot of efforts to ensure the quality of the software and especially the quality of the readers. Readers are not a very complex thing. It can be a tedious thing, though, if you want to make sure that all the cell types, all the variations of exports, all the difficulties in the interfaces are being handled properly. And it's not a strength in open source tools where a reader is going to be written by someone in a university. So at Intelligent Life, we take responsibility for all the readers that are in FieldView and to make sure that they're high quality and high performance. So that's just two differentiators, but I think it summarizes quite well the difference between all tools.
Presenting this information to our users. Again, to the users, thank you for your time today. I do invite you to visit their website, reach out to Shane. He's very helpful on trying to get you guys onboarded if you're interested in trying FieldView. And I think that's all we have.